You're standing in complete darkness. The temperature around you is 1000 degrees Celsius. Hot enough to melt gold, hot enough to vaporize lead. But this is the cool side. The side that never sees the star. Behind you, just over the horizon, the day side glows at 2400 degrees. Hot enough to turn iron itself into vapor. And right now, above your head, that iron vapor is drifting across from the day side. Cooling, condensing, forming droplets, and falling. It is raining iron. This is a real place. It exists right now, 640 light years from where you're sitting. And in 2020, we proved it. WASP-76b is what astronomers call a hot Jupiter, a gas giant, roughly the mass of Jupiter, but orbiting its star at a distance 12 times closer than Mercury orbits our Sun. One orbit takes 1.8 Earth days. At that distance, the star's gravity does something to a planet that our own solar system has never done to any world we live near. It locks it. Tidal locking, the same force that keeps one face of our moon always facing Earth. On WASP-76b, the star is so close and so massive that the planet stopped rotating relative to its star billions of years ago. One hemisphere faces the star. Forever. The other hemisphere faces away. Forever. They have never swapped. They will never swap. The day side, the side locked toward the star, sits at 2400 degrees Celsius. At that temperature, iron doesn't just melt. It doesn't just flow. It evaporates. It becomes gas. Invisible atomic iron drifting through the atmosphere like oxygen drifts through ours. The night side sits at around 1000 degrees, still hot enough to melt gold, silver, copper, aluminium, and most metals you have ever touched. But relatively cooler. And between the two sides, at the boundary where eternal day meets eternal night, winds of 18,000 kilometers per hour carry iron vapor from the furnace side toward the dark. 18,000 kilometers per hour. That's roughly 15 times the speed of sound on Earth. The wind isn't blowing iron, it's firing it. Now, here's the part that matters most. Because anyone can describe a terrifying planet, what makes WASP-76b different is that we didn't imagine this. We didn't model it. We detected it directly. Let me show you exactly how. In the Atacama Desert in Chile, at an altitude of 2,635 meters above sea level, sits the Very Large Telescope, operated by the European Southern Observatory. Mounted on it is an instrument called ESPRESSO, the Herschel spectrograph for rocky exoplanets and stable spectroscopic observations. It is one of the most sensitive spectrographs ever built, designed to detect the chemical fingerprints of distant worlds by analyzing starlight. Here's what it did. When WASP-76b passes in front of its star, starlight passes through the planet's atmosphere before reaching us. Different chemical elements absorb different wavelengths of that light. Each element leaves a unique fingerprint, a specific set of dark lines in the spectrum, an atomic signature. This is called transmission spectroscopy, and it lets us read the chemistry of a planet's atmosphere from 640 light years away. ESPRESSO detected strong ion absorption lines in the light coming from the day side of WASP-76b. Iron vapor, confirmed, but when it looked at the night side, the ion absorption lines were gone, replaced by a different signature, the signature of iron that had cooled, condensed, precipitated out of the atmosphere, and the signal was asymmetric, stronger at the evening terminator, where the day side meets night, than at the morning terminator. That asymmetry is the direct spectroscopic fingerprint of iron vapor crossing from day to night, cooling and falling. We detected iron rain on a planet 640 light-years away by watching it eat starlight. That sentence is true. Now let's go back to the surface. All three zones, one at a time. The day side. You cannot survive here for a single second. The temperature is 2,400 degrees. Your body, water, carbon, protein, vaporizes before you register any sensation. But if you could somehow observe it, from a distance, through instruments, here is what you would see. The star fills a significant portion of the sky. It is not a point of light. It is a wall of light, overwhelming. Close enough that its gravity is physically deforming the planet, pulling it slightly toward an egg shape. The atmosphere glows. Iron vapor absorbs and re-emits energy. The sky itself is radiating. There is no ground visible below. WASP-76b is a gas giant. There may be no solid surface at all, just atmosphere becoming denser and hotter and more pressurized the deeper you go, until the gases compress into something liquid, then something we have no word for. The Terminator. The boundary between day and night. If you could stand here, which you could not, you would be simultaneously facing a furnace and a void. The wind at this boundary reaches 18,000 kilometers per hour. It is not wind in any sense you know. It is a continuous supersonic blast carrying iron vapor, plasma, and atmospheric gases from one hemisphere to another. This is the most violent sustained weather system we have detected on any known planet. The night side. Darkness, but not cold. 1,000 degrees of darkness. And from above, iron. Liquid iron droplets falling through the dark atmosphere. The sky is not visible, but it's not empty. Lit faintly by the glow of iron burning as it falls, by the dim red light scattered from the Terminator. If there is a surface, a lower atmosphere dense enough to pull liquids, it would be accumulating molten iron, a landscape of liquid metal in eternal, superheated darkness. There is no safe zone on this planet. The day side vaporizes you. The Terminator blasts you at 15 times the speed of sound, and the night side rains molten metal on whatever is left. WASP-76b is not a curiosity. It is not an exception. Hot Jupiters, gas giants orbiting extremely close to their stars, with all the violence that proximity creates, are among the most common types of planet we detect. We find them easily because they are large, close to their stars, and their short orbital periods make them easy to spot. But their abundance means something uncomfortable. There could be billions of planets like WASP-76b in the Milky Way, billions of worlds where iron reigns, where winds travel at supersonic speeds, where the concept of a habitable surface is not merely unlikely, but physically impossible. We tend to imagine the universe as mostly empty and mostly quiet. WASP-76b is a reminder that this is wrong. The baseline state of matter under the laws of physics is not calm. It is not ordered. It is not gentle. Most planetary environments we find are not merely inhospitable. They are actively, creatively catastrophic. And then there is Earth. Liquid water on the surface, an atmosphere with breathable oxygen, a magnetic field deflecting radiation, a moon large enough to stabilize the axial tilt, a Jupiter-sized planet in the outer solar system, acting as a gravitational shield, absorbing comets and asteroids that would otherwise reach us. Every one of those conditions is improbable individually. All of them together, simultaneously on one planet, for billions of years, is a coincidence so extreme that it almost seems deliberate. Almost. We have confirmed over 5,500 exoplanets. Not one Earth twin. Not one planet with confirmed liquid surface water, a breathable atmosphere, and stable long-term conditions for complex life. Most places in the universe will kill you instantly and creatively. Earth is the exception so extreme it almost doesn't make statistical sense. You're standing on Earth. The rain outside your window is water. Just water. The temperature is somewhere between survivable and comfortable. The atmosphere is made of gases that support life rather than ending it. You are on a planet so statistically improbable that in over 5,500 confirmed exoplanets, we have never found another one like it. Not one. But last year, James Webb detected something in the atmosphere of a planet 120 light-years away. Something that, on Earth, is only produced by living organisms. Scientists have spent months trying to explain it away. They haven't been able to. That's the next video. If being a statistical miracle sounds like cold comfort, subscribe. The next one asks whether we're actually alone.